Today we're going to be talking about Chapter 3, so we're going to be talking a little bit about descriptive measures. That's going to be the mean, median, and mode. So pretty much what I want to point out is that the central tendency, whenever we're talking about that, that's actually just a fancy way of saying averages. The mean, median, and mode are actually all types of averages. We are most associating the average with mean though, where you would add everything up and then divide by the number you have. When we're talking about the median, the big thing I want to point out is that you have to order the numbers from least to greatest. From there, you have to find the middle number. And then if you have two numbers that are in the middle, so say for example, with 18, you would have your 9th and 10th number in the middle. You're going to take the average of those two numbers. And then the mode is the number that occurs most often. So here we're going to be talking about finding the mean salary for the data, the median, and the mode. So we have a law firm that hires college student interns to help with the caseload over the summer. Data set 1 represents the weekly salary of all the interns for the first half, and data 2 represents the weekly salary for all the interns for the second half of the summer. So when we're looking at how do we find the mean, so first of all, you're going to see that with mean is commonly represented as X bar. So here we're going to take the sum of all of our data points. So we're going to do 500 if we're doing data set 1 plus 450 plus 600 plus, and then we keep going on and on until we've added all of the data sets together for data set 1. We have 14 samples, so we're going to divide that by 14. Go ahead and do that. I'm going to give you a second to pause so you can actually find the average for both data set 1 and data set 2. So for data set 1, you should have gotten 535.71. For data set 2, you should have gotten 545. And when we're talking about the median, again, you want to order the numbers from least to greatest. So if we're looking at data set 1, I'm going to go ahead and start ordering least to greatest. So we have 400, 400, 450, and we're going to keep going until we actually have our largest value, which is 950. You're going to order the data set 2 the same way. And then don't forget the middle number is going to be your median. And if you have two numbers for that median, you're going to take the average of those two numbers, and that's going to be your new median. So go ahead and pause the video so that way you can go ahead and calculate the median for data set 1 and data set 2. For data set 1, you'll have gotten a median of 500, and for data set 2, you're going to get a median of 475. The mode is going to be the number that just occurs the most often, so we're going to go ahead and we're going to take a look what number actually occurs the most often. So I see we've got 450 here, 450 here, 450 here, 450 here. So that occurs most for data set 1. And if you're looking at data set 2, again, we have 450, 450, 450, 450. So the mode is actually the same for our two different data sets. So what does that actually mean? Why would we want to calculate the mean, the median, and the mode for both sets of data? If you're talking about a summer position and deciding whether you want to work summer 1 or summer 2, you might want to take a look at the mean. You could say, hey, look, interns are getting paid $545 for the second half of the summer, and they're only getting paid $535 for the second half. Or I'm sorry, the first half. So basically what we're doing here is we might be saying, hey, look, we need more, we pay higher for the second part of the summer than we do the first. If you're looking at the median, you might say, okay, well, with all of the interns from least to greatest pay, their averages are kind of similar. It looks like they might get more pay, though, in the first part of the summer instead of the second part of the summer. And then if you're looking at the mode, it doesn't matter which session you use because of the fact that whether you pick the first half of the summer or the second half of the summer, the most common salary is going to be $450 per week. So in chapters 1 and 2, we briefly discussed left-tailed and right-tailed skewed. You can see with the diagram again, if it's normal, the mean, median, and mode are going to all occur at roughly the same spot. Whereas if left skewed, your mean is going to be lower. At right skewed, the mean is going to be higher. So now we're going to talk about when we want to use the central tendency measurements and which one would actually be best for the situation. So if you're taking 5 exams in the class and your scores are 85, 93, 78, 88, and 96, which measure of central tendency am I most likely to use? If you said mean, you're correct. With the U.S. Census reporting all of the household incomes, which measure of tendency is most appropriate to represent the mean, or I'm sorry, not the mean, the average household income? For that one, we would actually be looking at median. Because you have Bill Gates, who makes more money than the majority of everyone in the world. And then you also have some people who are working at fast food restaurants who are doing their best to try to make their salary livable as well. So it wouldn't be fair to take an average because of the fact that, like an average is in mean, because of the fact that it would be skewed one way or the other. WCTC is interested in their enrollment status for men and women. Which measure of central tendency is appropriate to represent the WCTC enrollment? So we're looking at categorical. Because we're looking at categorical, we cannot take the mean, because the mean is the sum of all the values divided by the number you have, but we don't have numbers. We have male and female. Same thing with the median. You can't really organize male and female numerically because it doesn't exist. So in this case, for categorical data, you want to use the mode. Let's see, for summation notation, for some reason my slide didn't pop up, so I can go ahead and I can write some of this down. When we're talking about summation notation, that is going to be this symbol right here. And when we're talking about the average, that's what this is right here. So we have, if we're taking a look at our test data, so there are 5 tests. So we have 5 different samples, and that's going to be those 5 samples. So if you recall, our samples were 85, 93, 78, 88, and 96. And if you add those together, you're going to get 440. And then if we wanted to actually calculate the mean, that's going to be the sum of your data divided by the number of samples that you have. So n represents number of samples. So here you would have 440 divided by 5, and you would get 87. I think it's 87. I'm going to double check because that's just how I am. $88. I'm glad I checked. That's the one slide I didn't have written down. Okay, so from here, I want your turn. So you're going to go ahead and find the mean, median, and mode of this data. Go ahead and pause the video, and then when you're done, go ahead and hit play, and I'll have the answers ready for you. So your mean should be 98.9. Your median should be 100. And your mode should be 102. And I'm actually going to go ahead and duplicate this because what we need is going to be important for, undo. It's going to be important for our next bit of information as well. So, let's see. With here, we're looking at the blood sugar level of expecting mothers after eating. And you have 98.9, 100, and 102. So in looking at the argument as to what we would want to use and why, if we're a pharmaceutical company, which one do you think we'd want to use and why? I would think that as a pharmaceutical company, I'd be looking at the mode because I would be creating a medication that would be helping expecting mothers with their blood sugar level. If I am a doctor, I'm most likely going to go by the mean because the mean is going to be all of our representatives. And for the median, if I were a mom, I'd most likely look at the median because of the fact that I want to know for my own benefit, where do the expecting mothers tend to fall within their blood sugar level. So in talking about measures of variation, we actually are looking at range in sample standard deviation. It is a quantitative difference. I'm going to let you know right now, we're not going to do this part because we don't have a classroom setting where we can actually find the range. But we're going to talk about range in sample standard deviation as well. So in sample standard deviation, when we're talking about our normal bell curve, as you see below, right here, this part represents one standard deviation away from your mean, and your mean is always going to be in that center. So you can see here's 1 standard deviation, 2 standard deviation, 3 standard deviation. So as you're increasing, say I want to look at 2 standard deviations away from the mean, then I'm going to be looking at the 2 positive and the 2 negative. And all this in here, this would represent everything within 2 standard deviation of our mean. Look at it like throwing a dart on a bullseye. How close are you to the center of that target? So if you land right here, you might be 1 standard deviation away. If you land right here, you're 3 standard deviation away. So it just gives you that range to the center of the target. So how do we calculate standard deviation? Well, it's really not awful. We have to first find the average. So once we find the average, we're going to do something else with that. So go ahead and quickly calculate the average. Go ahead and pause if you need to. The average of these 10 values, okay, so you have 30 when you add them all together, divided by 10 is going to be 3 classes per semester. We have a pretty small sample, it's only 10, but I try to keep the numbers a little bit smaller for you guys to be able to work with them a little bit easier. So again, this data represents classes a college student takes per semester. When we're looking at having to calculate the standard deviation, so what this actually is saying is in this column right here, it is actually saying your value of the data minus the mean of your data. So what we're doing here is we would have 4 minus 3 equals 1. 2 minus 3 equals negative 1. 4 minus 3 equals 1. 6 minus 3 equals 3. And then you're just going to continue that all the way down. And your answers are going to be located right here. If you're looking at the dot plot again, remember, it's just going to be individual. It's based on unit rate. So here you have 1, 2 equal intervals, 3, 4, 5. 3 is pointed out. Here's where our mean occurs. Our median would be 3 as well. And our mode would actually be 4. If you're looking at our range is the difference between the highest value and the lowest value of our data. So the highest value of our data is 6, the lowest value of our data is 1, so our range for our data is 5. So now we're just adding on to the slide that we just had. And now we're actually looking at the squared deviation. So what does that mean? So first, let me go ahead and do this. So here we had 4 minus 3 is 1, 2 minus 3 is negative 1, 4 minus 3 is 1, and so on and so forth. To get to this third column, we're taking our second column and just squaring it. Whenever you have a negative value, any negative value squared is going to give you a positive value. So always your answer will be positive for this column. And then down here, you want to take the total. So you're just adding straight down. We're going to use this 22 in just a moment. So for our sample standard deviation, this is what that formula is going to look like. So this number right here is going to be 22. That's what we calculated from our column. We had 10 samples, so our denominator is going to be 10 minus 1. So that's going to be our formula for the standard deviation. If you do 22 divided by 9, you get 2.44. And I'm rounding. And if you take the square root of 2.44, you're looking at approximately, so I'm going to make that little wavy equal sign, which means approximately 1.56 classes. And that again is rounded. One thing I want to point out, again, we're looking at the more variation that there is in a data set, the larger the standard deviation. So again, we're looking at how close together is your target, or is your target more spread out? So what does this mean? We said that our standard deviation is about 1.56 classes. This means that, roughly speaking, on average, the number of classes the sample population takes per semester varies from the mean of 3 by about 1.56 classes. So we're saying that if we're talking about the one standard deviation, if this is our bell curve, our mean is 3. This is one standard deviation away, so here's your +1 standard deviation, -1 standard deviation. That is going to be 4.56 and 2.44. And looking at further interpretation of the standard deviation, we have dataset 1 and dataset 2. If you look, the averages for dataset 1 and dataset 2 are equal. So the average of the numbers are both 50. You have a standard deviation of 7.4 and 14.2. So that means that this is going to be closer together, and this is going to be further apart. So if we're looking at a normal curve, that would be for your dataset 1. That might be for dataset 2. So it looks like it's a little bit flatter, it's more spread apart at the base. As a general rule, we expect almost all data observations to fall within 3 standard deviations of the mean. We're going to go into the empirical rule in a moment, but with that the ±3 standard deviation, that's going to give you 99.7% of the data. So again, we don't have a break. If you need a break, feel free to pause the video at this point. For the empirical rule, this is the standard for most economics. I'm sorry, it is for economics, but it's also for statistics. We have the bell curve right here. Property 1 says that about 68% of all observations lie within 1 standard deviation of the mean. And again, we're going to go into all of this in greater detail in chapter 6. So right now, the main focus is with the empirical rule, what does that mean? So within one standard deviation above or below the mean, we would expect 68% of our data to fall in that range. About 95% of the observations would lie within 2 standard deviation of our mean, and about 99.7% of all of our observations would lie within 3 standard deviation of our mean. So here, what I want you to do is to find the mean. Then I want you to find the frequency table, create a dot plot, and look for the bell pattern. And what I'd like for you to do is to go ahead and pause the video and take some time to go ahead and do that right now. As you'll see here, even with the frequency table, it gave you the bin spread. So here, I don't know why this isn't showing up, but my graph is not showing up. We would have a graph, and we're going to have our bin categories. So we have 54 to 57, or I'm sorry, 56, 57 to 59, 60 to 62, 63 to 65, 66 to 68, 69 to 71, and then we would have that last column as well. So when we're looking here, we can see here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for our histogram, we would be looking in our first one we have at 1. For 57 to 59, we don't have anything. So again, we're going to do for 60, it goes up to 6. And we can shade that in. For 63, that goes up to 9. And we could shade that. For 66 to 68, we have 4. (69 to 72, we also have 4. And then for 72 to 74, we have 1. And if you're looking for that bell shape, you would see you have your peak. Here's the 5-number summary for the box plots. The 5-number summary, you're going to want to look at the first quartile, second quartile, and third quartile. So the first quartile, we're going to go into what the first and the third are. That second quartile, though, that's just the median. So in determining quartiles, what you want to do is arrange the data from least to smallest. Then you want to find the median of the data. And here again, the data for the median is going to be the second quartile. Then you're going to divide that data into two halves. So the bottom half of the data is going to be your Q1. The top half of the data is going to be Q3. So you have to find the median of the bottom half, and you have to find the median of the upper half. So if we're looking for the Q1, Q2, and Q3, you want to order this from least to greatest. So the first thing I'm going to do is, and I'm not going to mark the extra zeros, so that way it's a little bit shorter for me. So we have 39,000, 41,000, 42,000, 45,000, 45,000, and we're going all the way up to 83,000. When you order them out, you get that your median number, so your Q2, the number that's actually in the middle, is going to be an average. That average is 54,240 and 50 cents. So that's going to be your average. Because of the fact that you get a number that you had to find the mean between those two, you're not actually counting that for Q1. So when you're looking at Q1, you're going to be going from 39,000 all the way up to 53,376. So you're really using the mean of that data because our Q2 isn't an actual data point. That being said, then you're going to get Q1 being 45,000. For Q3, again, the $54,240, that's not going to be your main point. So you're finding the median from $55,105 to $83,000. So your Q3 is going to be $67,000. In writing for our 5-number summary, don't pay attention to this. Our 5-number summary is going to be the lowest value. So we have 39,000 as our lowest value. Then we have our Q1, which is going to be 45,000. Then we have our median. Then we have our Q3. And then we have our highest value. So this is your 5-number summary. If we're trying to find the inner quartile range, so that inner quartile range is going to be Q3 minus Q1. So you have 67,000 minus 45,000, and that gives you 22,000. This right here is your inner quartile range. That number is going to be important for us to reference because we're going to try to find any outliers with our data. So outliers are significant values that skew our data one direction or the other. So when we're looking at the lower limit, you have to do the Q1 minus 1.5 times your IQR, or Q3 plus 1.5 times your IQR. So we already said, here's our IQR. That's going to be 22,000. We know the Q1 is 45,000. Okay. We're going to subtract 1.5 times 22,000, so we have 33,000. Our lower limit is going to be 12,000. So I'm going to put LL. Our upper limit, now we're doing Q3, so 67,000, plus 1.5 times our IQR. And that's going to give us 100,000. And that's your upper limit. The reason why your limits are important is because of the fact that if, say for example, somebody's salary was $102,000, that would be considered an outlier because it's outside of that range of 12,000 and 100,000. So if we had 102,000, again, that would be an outlier. In constructing a box plot, we use our 5-number summary to construct the box plot. So just for example, we would have our lower number, or our minimum here. We'd have a little whisker. I called it a box and whisker plot when I was growing up. You have your Q1. Q1 to Q2, you have a box. You have a box also to Q3. And then here you have your max. The reason why this is boxed is to show the 50% of the data lies within this box right here. If you do have an outlier, so say for example, we had an outlier above our max, what we would, or our max is actually an outlier. So say for example, it was that 102, what we would do is we'd actually put an asterisk wherever that number would fall, but then we would put the next highest number for our max. So here are some box plots for the age range of people who own BMWs. So what does this mean? And what do you suppose the spread means? So no matter what, you have 25% of your, the people surveyed there, 25% here, 25% here, and this whole thing is also 25%. 25%, 25%, 25%, 25%. So first of all, what I'm noticing is that as the BMW series increases, so as you move from a 3 series to a 5 series to a 7 series, your mean age is going to be increasing, and your median age is also going to be increasing. Because here's the median, here's your median, and here's your median. So the median age is increasing based on what type of BMW you have. Well, what might cause that? If you know anything about luxury vehicles, when it increases, so does the cost. So younger people might have a BMW 3 Series because of the fact that a BMW 7 Series costs significantly more, and they just might not have that money saved up. So there's a lot of different reasons. Plus, a BMW 3 Series is going to be a little bit smaller. The BMW 7 Series is going to be a little bit bigger. So maybe you're upgrading because you have a family now. This is what box plot skewness would look like. So when your box is on the left-hand side, you're looking at more of a right skewed data set. When your boxes are pretty much in the middle, it's symmetric, and when the boxes are on the right, then it's going to be left skewed. Looking at descriptive measures, so when I said that X bar is your mean, for X bar, when X bar is your mean, that's your sample mean. And then for mu, okay, so this is mu, that's your population mean. It'll be really important to know the difference between these two symbols because as we move towards talking about distribution and hypothesis testing in Chapter 6 and Chapter 7, you need to know the difference between the population mean and the sample mean. So here is some sample data of the kids that I nanny over this summer. This is the first summer I'm not having to nanny them, so it works out for me. Love the kids though, they were great. The first thing that you want to do is to find the mean age of the kids. And if you add up all of the kids' ages and you divide by the fact that I had 7 kids, the average age is 4.43. Okay, so notice that the population standard deviation is going to be just a little bit different. And I digress a little bit because actually with the kids that I nanny, it's not a sample. That should really be population. Because these are all of the kids that I nanny. So that is the population for all the kids I nanny. So if I want you to find the standard deviation, what you need to do, we'll do the little chart again, and I'll talk you through it. Notice how the big difference here with your sample, okay, so your sample standard deviation, that's going to represent by S. Your population standard deviation is represented by the omega symbol, or the sigma symbol, sorry. We also notice that we're not subtracting by 1 in our denominator, okay? When we subtract by 1 in our denominator, that allows for a little bit of error. When you actually know your population standard deviation and you know the sample in there, you don't need that error. So again, I want to point out that we are looking at the mean is going to be 4.43. So I'm going to give you a moment to fill everything out here. Go ahead and pause the video. And now that you've found your standard deviation, you'll see the data over here. With your standard deviation, it was 67.7143 is what I put, divided by 7. That whole thing was square rooted. So then you get the population standard deviation, you get 9.6735. And if you actually take the standard deviation there, you get 3.11. So that's the standard deviation for the kids that I nannied. Looking at the population versus the sample, so this blue circle represents the population. each of the black circles represent one part of the sample, so each data collection. We have more definitions here. For parameter and statistic, the parameter is just a measure of the population, and statistic is going to be the descriptive measure. When we're talking about the z-score, this is going to be a huge part of chapter 6. So the big thing is I'm going to want you to learn how to calculate to find the z-score right now. We'll go into more detail as to what it actually is in chapter 6. So for the z-score, it's an observed value of a variable x. The corresponding value of the standard variable z is called the z-score of that observation. Okay. The term standard score is often used instead of z-score. I keep using z-score. You don't have to worry about that. When I say back to being Mary Poppins we go, Mary Poppins was a nanny for the kids, so we're going back to the nanny problem. So we know that our population mean is going to be 4.43, and that's in years. We know that our standard deviation is 3.11 years. And if I want you to find the z-score of Jane, Jane is 8 years old. We're going to substitute the values in to find the z-score. So our z-score is equal to our sample minus our mean divided by the standard deviation. And there you get 1.15. So this means that the age of Jane is 1.15 standard deviations above the mean. If we want to talk about Maggie, okay, so the z-score for Maggie who's 2, now we're doing 2 minus our mean, all divided by our standard deviation. And that will give us negative 2.43 all over 3.11, which will give us negative 0.78. And that's pretty much everything that you need to know for chapter 3. If you continue on to the next slide, there is a website for Microsoft Excel to help you with that. I also have it located in the additional video section on Canvas. If you have any questions at all, please let me know. Chapters 1, 2, and 3 are what's going to be on your first test. Don't forget, with the homework, try to turn the homework in the same day you turn the test in. If you want me to go over homework ahead of time, that's fine. Just send it to me and I'll take a look at it.